Well, it happened. I decided to take a day off. I feel terrible. And I'm sorry I'm not there with you guys. But we're going to push on. Hopefully, you've already gone over the 6-4 day 2 homework answers. Those are in files. So please check those over. Make sure you're good with them. Today's a little bit different. We're going to introduce some new things. And if you remember, if you noticed over the last couple days, when we were doing that division with the power and the index, it always turned out really nice. Well, today it's not going to turn out so nice. I'm going to show you how to deal with that, okay? And then we'll add a couple other wrinkles to it and be good to go. If you are listening with headphones, that's fine. Taking your own notes, that's fine. If you'd rather project it to the TV and that's what the majority of you want to do, that is also fine. Just be respectful of each other and respectful of the substitute today so that everybody can be productive and feel like you're getting the stuff done you need to get done. So, here we go. Also, if you missed a quiz or need to take a quiz or whatever, you just have to do it on Monday. I'm sorry, I didn't feel like leaving that for this other. Didn't seem fair to me. So, do it on Monday, another weekend, I guess. I hope you guys are feeling well. All right, here we go. So, here's a couple problems. Go ahead, take a picture, write it down, whatever you want to do. And pause it as you do that, or screenshot it if you're just listening on your headphones. And I'll kind of walk you through these and how to do this. The first couple parts aren't going to be too bad. It's going to be pretty normal-ish. It's when we get to ones like this, and actually that 12, since it's not a perfect square, we'll talk about what to do with that, because we're not going to just enter that in our calculator. I know in the 6-4 homework I kind of showed you how to split them up, and I'm literally going to split them up this time. So for this first one, what you really want to think is the square root of 12 is one part of it. The square root of c to the 6 is one part. The square root of d to the third is its own part. Okay, we have an even index, so we have to be on guard for even, odd, even here. So whatever this turns out to be, we may need to have an absolute value. We'll see. We have even odd here, so it's not in play. Okay. The way we want to deal with the square root of a number that's not a perfect square is we want to try to find the biggest factor that goes into 12 that is a perfect square. Okay, so think about that for a minute. Think about your factors of 12 and what factor of 12 is a perfect square. Hopefully you came up with 4. And so what we're going to do is get that down to 4 times 3. And we can simplify that. We know what the square root of 4 is. That's just 2. We can't take the square root of 3. So the 2 comes out. 3 stays put. So for that part of it, the square root of 4 is 2. And even if you wanted to think of it like this, the square root of 4 times the square root of 3, you could do that. You could separate it that way. Or you can just know the square root of 4 is 2 and it comes out in front. Can't take the square root of 3, so it stays underneath. Now, I already alluded to this one. We've got the even. All right, this is a 6, this is a 2. We're going to divide them, so I get a 3. Okay, so that's 6 divided by 2, like we did before. That gives me c to the third. Got to be careful now. We actually have an even, odd situation, so we're going to need absolute values. I'm not going to put them in quite yet. Here's the part where it gets a little bit different, right? I've got 2 there, and I'm going to divide 3 by 2. I'll write it in there in case you need it. Okay? It doesn't go in evenly. And so what we do is we write it like old school division. 2 goes into 3 one time, remainder 1. Why this is important, and notice my colors. The 1, the number of times that it goes in evenly, becomes the power outside the radical. The remainder becomes the power inside the radical. So what I really have is d, because we're talking about d to the third. We're talking about d to the first, because that's how many times it goes in evenly. And my remainder is 1, so then there's a d with the first power still inside the radical corresponding to that remainder. So just let that sink in a minute. Look through it, pause it, see if you can follow what's going on there. So there's no nice, clean way to write the square root of d to the third. Well, I can't write d to the third as something squared without using fractions, which we don't want to do yet. All right, so instead what we do is we just do the division like we've been doing. It just doesn't turn out even, okay? It goes in one time, and that's the power on the outside, so that's how many d's come out. Another way to think about it, honestly, actually, I'll write this over here. This is the square root of d squared times d. Well, I can do the division here. Square root of d squared is d, so that's why it's out front, and I'm left with a d on the inside. That's why this all works. Okay? So that's the first one. Second one works the exact same way. Okay, I've got an odd index, so we don't have to worry about absolute value. Oh, I guess we're not even done here because I didn't bring them together. We got to bring them together. Sorry, got ahead of myself. Because what we're going to do is we're going to take the stuff on the outside of radicals and combine them, and the stuff on the inside of radicals and combine them. Okay, so I color coded it for you. This is all the stuff on the outside. Okay, so in front of the radical, I'm going to have 2c to the third d. Underneath the radical, I have a 3 and a d. So simplified form looks like that. But we talked about the even, even, odd, so I need to have those absolute values there. Okay, and just around the even, even, odd part. Okay. Here I didn't have an even, so it doesn't apply to the d. Okay, it doesn't apply to this d, and d was to the odd power, so we don't have to worry about that. Okay. All right, now let's move on to the next one. Again, I want to think of them as three separate things. Easy, easy, a little tougher. Give that a shot, pause it, and see what you come up with. All right, cube root of 27, easy P3. Okay. Cube root of y to the 12th, 12 divided by 3, that just gives 4, y to the 4th. Again, nothing under the radical, we're good. Here's where I run into an issue, because I'm going to have a remainder. So I'm going to go 7 by 3, which is 2, remainder 1. Okay, so the 2 becomes the power on the outside, so it'll be z squared on the outside, and I'm left with z to the first on the inside. Okay, it's still cube root, don't change that, don't lose that index, it's still there. I've got my stuff on the outside, it's actually all right here, and I've got one thing on the inside. And again, odd index, so we don't have to worry about the even, even, odd stuff. So no absolute value, and then I'm good to go. There's my answer. 3 y to the 4th z squared, cube root of z, that's still left underneath. Okay, so there's where it gets a little bit trickier when you're dealing with this thing. But again, the division, the number of times it goes in completely, is still the power on the outside, like it was here. Okay, the remainder is the power on the inside. Okay, let's try a couple others. Here's where it's going to start to get a little more complicated, because we've talked about rationalizing denominators and not having square roots on the bottom. Well, we're going to have a little more of that going on now, but it's not just going to be square roots. Okay, we're going to start with that. So here's my first problem. I've got the square root of a to the 9th over the square root of b to the 5th. What you should do first is simplify the top and simplify the bottom to pull out whatever you can, like we did on the last couple problems on the previous slide, to simplify it down first, and let's see what we get. Hopefully we won't have any radicals in the denominator, but yeah, we're gonna. So on top, I've got 9 divided by 2, so that's 4 remainder 1, so that means I'm going to have an a to the 4th on the outside, and a remainder of 1, so that's a to the 1st. And then the bottom, I've got 5 divided by 2, so that's b squared, remainder 1. That's going to be on the inside. A little cleaner looking version of that. Okay, so again, 9 divided by 2, 4, remainder 1. That's the power on the inside. 5 divided by 2, 2, remainder 1, there. I still have a radical on the bottom, so I have to change this so that I no longer have a radical on the bottom. And the only way to do that is to multiply it by another square root of b, because then I'll have 2 square roots of b, which is the square root of b squared, and then, so in reality, what I'm going to do is this, which is the square root of b squared. The radical and the power cancel. This concept's going to be pretty important on the next problem, except it's not going to be this easy. So, going back to it real quick, this is why I showed you this, because this really is b squared, so that they cancel, okay? But in this section, what I'm going to do, multiply top and bottom by the square root of b, okay? Since the square root of b times the square root of b is b, and I already have a b squared down here, okay? It's really b to the 3rd, and again, I'll just write this out if you want. So this is b squared times the square root of b times the square root of b is b, and that's where that comes from. And then up here, I just combine it all under the radical. Square root of a times the square root of b, all underneath the radical, And that's my final answer, okay? This concept here is really important. Because it was a square root, I needed b squared, okay? We're going to look at some with an index that is not 2, which means you got to be thinking about how many of those do I need in order to get the radical to cancel, and that's what's coming next, okay? And here it is. So this is the fifth root of 3 over 4y, which really means, right away I just split them up. Split them into two things, okay? Essentially what I need is to have something to the fifth power down here so that it cancels with the fifth root, okay? Now, you might say, okay, I just need to make this 4 to the fifth and y to the fifth. The problem is, in that particular problem, in this particular problem, 4 already is an exponent. If you're thinking about 4 written in terms of powers, you're going to use some other number and raise it to a power. We can do that, which allows us to make sure we have the smallest possible number. Now, you could multiply this by 4 to the fourth to get 4 to the fifth, but there's a good chance, and I can guarantee it would happen here, that you would still have to reduce afterwards, after you're done. If you can find a number that can be rewritten as a power, you should do that to make the smallest possible numbers that you can have. So, as you know, how would I rewrite 4 using some exponent? Some number to some power equals 4. Of course, we all know that that's 2 squared, okay? So I want to think of it as 2 squared, and here's why. I already have two 2's. If it was 2 to the fifth, then it would cancel with the fifth root. And then I'd be good. Now, the y is the y. It's y to the first. I'm going to need y to the fifth, so I'm going to have to multiply it by another y to the fourth. The trick is it has to be the fifth root of that. So, again, thinking strategy here. Okay, when we rationalize denominators with square roots like we did on the other one, I only had to multiply it by one more because I already had one. That gave me a total of 2. In this case, with the fifth root, I need a total of 5 so that the fifth root and the something to the fifth power cancel. And we have another twist because 4 can be written as 2 squared. If this was not a 4 and it could not be rewritten as a power like this, then you would go times 4 to the fourth, okay, or 3 to the fourth, or 7 to the fourth, or whatever that number was that couldn't be rewritten that way. So instead, since I have 2 squared and I need it to be 2 to the fifth, I need to multiply it by, hopefully you said 2 to the third, because that's where I'm going to add the powers. So here's what we're going to have, okay? I'm going to multiply this bottom, because 4 really is 2 squared, by the fifth root of 2 to the third, and the reason again, because when I combine these together, it's 2 to the fifth. Y to the fourth times y is y to the fifth. So what's going to happen is I have everything now rewritten to powers that match the index, so that they cancel, okay? And now, of course, if I do it there, I have to do it to the top too. Okay, I'm just going to focus on the bottom right now, though. And eventually we'll get back to multiplying it by the top. So notice what I did. I just combined this all together. So 2 squared, because it's all under the fifth root. They're both under fifth root, so I can multiply them together. 2 squared times 2 to the third is 2 to the fifth. Y times y to the fourth is y to the fifth. So I've rewritten everything under here as something to the fifth power, which means they'll all cancel out. Which is good, because then I won't have a radical anymore. Okay? So I'm just going to keep finishing on this and show you that cancellation. So the fifth root, 2 to the fifth, they cancel, gives me 2. Fifth root, y to the fifth, they cancel, gives me y. So what I have on the bottom now is just 2y. Okay? If you didn't notice this and you went 4 to the fourth here, then you'd have a 4 down here. And I'm going to show you what would happen if you did that. You'd have to keep going. Now, as we know, you can't just multiply the bottom by something. You have to multiply by it too. Okay, and I happen to rewrite 2 to the third as 8 because it's going to get multiplied by 3. Okay, and then the y to the fourth is fine under there, and so that's my final answer. Okay, the fifth root of 24, y to the fourth, and then I'm going to slide that over, and that's my final answer. Okay, so there's a lot of concept there. Understanding with rationalizing denominators, our goal is to rewrite it as something to whatever that index is. If this was a 3, you'd need to write everything something to the third power. If this is a 4, everything to the fourth power. So it all cancels, so I don't have a radical on the bottom. which is why I showed you over here. We just make it a lot more complicated because you can handle it. All right, a couple more things to go through and then we'll be done. Okay, here's, we're going to do, I'm going to say 2 problems like this. So when I've got numbers on the outside, numbers on the inside, we can combine together. Okay, we can combine the numbers on the outside together. We can multiply the numbers on the inside together. Okay, so on the outside I'm left with 24. On the inside I'm left with 16 c to the 4th d to the 8th. Now, you could try to simplify them individually, but most of the time multiplying them together makes the numbers nicer and makes it easier to deal with. Okay, now one thing to understand, actually it's not going to apply here anyway, so we're good. Okay, square root of 16 is 4, so a 4 comes out. Square root of c to the 4th, 4 divided by 2, c squared. Square root of d to the 8th, 8 divided by 2, d to the 4th. Okay, so that's what I have here. When I just simplify that, now I multiply the 24 and the 4, and I'm done with that one. Okay, give this one a shot. Do this one yourself. See what you get. Pause it, come back. Alright, same deal. When I have a radical, I can multiply the things on the inside, and the numbers on the outside I can multiply together too. So when I do that, I get a 6 on the outside, 2 times 3. 8 times 2 is 16. X to the 3rd times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. Okay. 4th root of 16. What's that? What number to the 4th power gives me 16? Put it in your calculator if you're not sure. Alright. It's 2. 4th root of x to the 8th, that's x squared. And 4th root of y to the 4th, that's y. Ooh. We're going to mark that one. Okay. So we got an even, even. And here I have even, even. And here I have even, even. And there I have an odd. Okay. So you want to go back and refer to the original problem. Since I have even, even here, even, even here. I don't have it with the x, even though I have it here. And granted, this is even, even, even. But because these are raised to the odd power on the inside, I have even, odd to begin with. So it doesn't apply. But with the y's, I have even, 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 even. Now I have even, even, odd. We got a problem. I have the absolute value in there. And then my last move is just to multiply 2 times 6. And there's our final answer. Alright, that is 6-5 day 1. Help each other, work through it, get it done over the weekend. Again, I apologize for not being there today. I just don't feel good. Hopefully you got this done. You'll get it done. If you have questions about anything, feel free to email me. I'm just going to be laying around tomorrow and probably all weekend. So I'm happy to get back to you that way. Also, if you have quizzes that you need to make up, you can take them Monday. And I'll be happy to sign your registration forms or have those conversations with you if you need to. Take care. Have a good weekend.